G'day there, you're watching the Aussie BIM Guru. Today I've got a video that's going to hopefully help some people out that are trying to track RFIs on a project based on a Revit model. So this actually came from a specific request, so yeah, I thought I'd do a video based on a workflow that I thought up. So thanks for the idea to James Hilligus. I've actually spoken to James a few times in the past, quite recently, and he's doing some brilliant work using BIM and Revit and models out on site. So definitely check out his channel if you're looking for some great examples of how you can apply BIM to the construction site. But I noticed that he had a workflow that he was looking at for RFIs, and I told him that I had an idea in Dynamo. So his original workflow was that he was placing text notes and detail items or hatches over a floor plan in order to generate I assume a print or a drawing that he could send back to the architects or the engineers, and then associate the RFI number in his text note with I assume like a Word document or an Excel file or a common data environment with the numbers assigned. I assume that this is probably generating the RFIs as well. So as he places his text note, he probably describes the RFI somewhere else. So my idea that I'm going to show you how to do using Dynamo is to use 3D RFI families to mark the RFI, get its location and its data out to Excel, which can then allow you to give that data over to an architect or an engineer who can go back in their model and place the markers with the data to actually go and find these issues in context. So let's just get started. I'll show you my idea. Okay, so I'll just jump into, Revit 2020. And I'm just going to have to stop Revit 2019 from loading up. Cool, so the first thing we need to do is make an RFI family. So what I'm going to do, it still loads anyway. Got a lot of Autodesk sometimes. Go away. Don't know if anyone else finds that the programs are very hard to get rid of sometimes when you don't want them around. Cool. So we're going to make a new family, and we're just going to make this a generic model, just a standard generic model. I'm going to make it a work plane based family and a shared family. And all I'm going to put in this model to begin with is some model text. And I'm just going to call this model text RFI. And I'll just place that. Go to edit type. I'll pick a nicer font, just do Arial black. And let's just make the font size 450, make it a bit bigger. I'm just going to center it. And then just place it just above the reference marker point. What I'm going to do then is make a new family again. And I'm just going to make a generic annotation. So I'm going to go to annotations and just get a generic annotation. I'm going to make a label. I'll just click once, and I need to make two parameters. One is going to be the number, so I'll just call this RFI number. And we'll just make this a text parameter and an instance-based parameter. And we'll add that. And then I'll make one called RFI status, where the user can specify the status. So we're going to be adding this into our generic model. So what I'll do is just make sure there's a line between these. So I'll add a break. I'm sort of skipping through this bit because it's not really that important. It's just really creating the marker. And I'll just load this into the generic model family. Won't save it. Click once, and we'll just put in XXX, so you can see our text. We'll go to 1 to 100. A working scale, and we'll just move that up. Then what I'll do is I'll nest two text parameters in here. So I'll just nest in RFI number as an instance-based parameter, and RFI status. That's my cat. It's an instance parameter. And then I'll just quickly save as, just in case I crash. I'm just going to call this marker, and I'm going to load this into my project. So what we have now is essentially a family that we can place anywhere we want. So let's say we notice a problem in our model and we're doing an RFI review. Let's say this is meant to have two doors, this room, for some reason. Click on my RFI marker, type in the number 001, and I can say status is open, and I might add one extra parameter into the marker. But in this case, I'm just going to add it as a piece of data. So I'm just going to call this RFI comment. So I'll make it instance-based, and I'll make this a multi-line text field. Let's make that again. And by default, I'll just put in 1, 2, 3 as the comment, just so it has something by default. Save, load it back in. And the reason why I make it a multi-line text field is even though I'm not going to press enter and use it as a multi-space text block, I just like the ability that you can bring up a text editor instead of typing it in the parameter slot and then commit with an OK when you're done. It's much easier than hoping that you don't lose the control of the text in the properties browser. So I'm just going to say, you know, isn't not a door here. Probably not like a very relevant RFI. I'll just copy my RFI marker and let's go find another one. Let's just make an RFI saying, what is this? What is this? And what I'll do is I'll just make one more on this level. Where did the door go? What I'll do is I'll just copy this marker and I'll just go up to another floor. Because most projects you'll be working across multiple floors with RFI management. Let's make one in here, and let's say this is my office. So I'll make this one 101. And I'll make the RFI, can you make my office bigger? Nice and corrupt. Okay, so we've got a few RFI markers in our project. They're also technically a 3D object, so you should be able to see them in 3D if you need. But at the moment, we'll just deal with them in plan. So what I'm going to do now is I'm just going to go to Dynamo. So I'm going to manage, open Dynamo. And what we're going to do is build a workflow that can export the data from these markers out to Excel. And then we can return that back to someone else's Revit model. So the first thing I need to do is actually get my family marker. So I'm going to go to family types and just scroll down to my family at the end of all the metric families called marker. And then I need to get all elements of family type. So this will collect all of my markers. So now we should have those 4 markers. And what we can do now is the first thing I'll do is I'll get their location. So I'll just look for location, because apparently get location doesn't find get location. Get location. Okay, so we should get their location as points. So what we want to do is deconstruct these into their x, y, z components. So I'm just going to make a code block and say x equals p.x. And the .x syntax will get the x coordinate of a point. Likewise, I'll do y equals p.x, so the same point, and z equals p.z. Actually, sorry, p.y previously. Whoops. So if I feed this in, I'll get 3 sublists of the x, the y, and the z points. So there's the z points, for example. Okay, so the next thing we need to do is use the element get parameter value by name. And we're going to get a few parameter names. So I'm just going to build a list using a code block. And I'm going to get RFI number. I'm also going to get the RFI status. And I'll just check what I called the comment parameter. Can't quite remember what I called that. RFI comment, of course. All right, RFI comment. So that's our 3 pieces of data we want, but I'm also going to get the level that they belong at. And I'm going to run that at level 2 so that for each parameter in this list, I'm finding their respective value of each family that enters this node. And I'll just make myself set to longest lacing as well. And what we should get is a list of values per marker. And you can see our data coming through now, including our levels. And our levels at the moment are just the element in Dynamo. It's not the name of the level. So what we'll do first is just transpose our data so that instead of by parameter, it's by element. So this will flip our list so that now the first set is our numbers, the second is our status, comment, and level. What I'm going to do now is split my data up. So I'm just going to say num for number equals list index 0, stat for status is list index 1, com for comment, list index 2, and level equals list index 3. And this essentially just breaks my data into separate rows that I can work with. So we'll see at the moment the last row in our code block, which is the levels. What I can do with that is get the level.name node, and then I can get the name of these levels instead of the level itself. So this is obviously Excel-friendly readable data. What I'm going to do now is just put all my data back together. So I'm going to make 7 inputs, and I'm just going to collect my number, my status, my comment, my level, my X, my Y, and my Z. What I'm also going to do is just build a list up here, and I'm going to name my header rows. So I'm going to get my number, my status, my comment, my level, X, Y, and Z. What I'm going to do then, and this is a really handy little trick I do quite a lot when I'm inserting header rows, if I insert the item to the list, it won't give me what I want. It gives me all the items on the front of my lists, which isn't what I want. You could transpose and then add it and then retranspose. That's one option. So we might actually do that. But sometimes what you can also do is you can add at level 1 and at level 2. And to the front of each list, it will add each item in this list. So you can see now number gets added to this list, 1 gets added to this list, etc., etc. You could also just use transpose and turn off levels, which is what we'll do in this case. So we'll transpose our data. This will give everything in that structure. And then we'll add our header row to the front of our data. So that works as well. Okay, so what we're going to do at the end is just export our data to Excel. So I'll just get a file path, and you'll need an empty Excel file. In my case, I'm just going to use this write2 file that I've already set up. We're going to feed in our data. We're going to call in our sheet, which in this case is called sheet 1, the default sheet in Excel. Our start row and column is 0, and we do want to overwrite true. So sheet 1, 0, 0, and we do want to overwrite. Okay, at this point, I should be able to run this script and write my values to Excel. So you can see there's our header rows, and here's our data as it's come into our model. You can see some things do get formatted in Excel, so it can be a little bit unfortunate depending how you name and number certain values. You can see, for example, that RFI 001 became 1, 2, 3. You could work around that by converting these objects into strings, for example, and then adding something to the front of them and then removing it later on. In this case, I'm just going to let it slide. But yeah, there are ways you could process that data. So what I want to do now is actually build a new script, because at this point I have data. So let's say that I am the architect or the engineer, and I have this family because my builder's been very friendly and given me their RFI family and said, go run the Dynamo script and you'll get the RFI markers. So I'm just going to get rid of all the RFI markers. So imagine that I'm just in a blank model. I've got the family in the project. So what I'm going to start with is, instead of exporting Excel, of course, I'm going to import Excel. So I'll have a file path, and I'll path to that file from before. I'll get a file from path. Wow, that cat's going crazy. I'm going to import Excel. So this is where I'll get my file. I know that I'm getting it from sheet 1, and I don't want to open Excel or read as strings. So at this point, I should be able to obtain the data in an Excel format. What I'll do now is I'll use a rest of items node in order to drop my header. And this will just leave behind everything that is data. What I want to do now is transpose, just to flip my rows into columns. And you'll see now we get our numbers, status, our comment. So we're getting our data back in a structure that we can work with. At this point now, we need to split up our data so we can process it. So again, we're going to be saying num equals list index 0, start equals list index 1, equals list index 2, level equals list index 3, x equals list index 4. So this time we have the x, the y, and the z. List index 5 and z equals list index 6. And now we're going to split our data into all its respective pieces. And we're going to do a bit of processing. So the first thing we're going to do is we're going to build the location for these elements with a point by coordinates using the x, y, and z. And because we're working in the same model, will be in the same coordinate system, so we won't have to worry about translating any coordinates around. In this case, you can see we're getting the geometry scaling error, so if you see that, you just go setting, geometry scaling, extra large, and that should manage out that warning. What we'll do then is we need to find the levels by name. I'm going to use just a little trick where you check all the names of the levels in the model and then find the index that that name occurs at. There's other ways you can do it, and there's some custom nodes that I think will just retrieve levels by name, but I'm just going to do it the out of the box way. So I'm just going to look for the category of levels. So I need to type in levels with an uppercase L. I'm going to get a category by name, and I'm going to get all elements of category to get all my levels. And at the moment we don't have their name, we have them as elements. So we do need to get that level.name node. And I'm just going to create a pathway down here because we're going to be eventually drawing some data back out of our levels. And I need to get an index of, an index of in a list. So in this list of level names, we need to find the index that the level's name from Excel occurs at. So you can see that we've got 3 that occur at level index 0 and 1 that occurs at index 1. Because remember we had that RFI that was up on the other floor? Okay, so what I can do now is just feed these into a get item at index. And we'll take our list of levels that we took the names of and then feed these back in. And this should convert our levels based on those level matches. And you can see there we are. We found those levels as they match. So what I need to do now is just obtain a little bit of data and pull it forward. So in this case, I'm going to put these 3 pieces of data together, my number, my status, and my comment, in a list. And this is because I want to transpose them so that they're sorted by object rather than by parameter. So in this case, we have the 3 parameter values as they apply to each marker. We have their level and we have their point. So as you'll expect, we're going to be using a node that can use this data. So we're going to use a family instance by point and level. We're going to get a family types drop down. In this case, it's going to be the marker family. So we need to find that marker family. So this is our family type, this is our point, and this is our level. And then we have some data to write. So at the moment, if I ran this node, I wouldn't be writing any data, I'd just be placing families. So what I need to do is also set the parameters by name after the family's been placed. So this node will give us 4 family instances as they come out in Revit from Dynamo. I want to write 4 parameters here. So I want to write RFI number. I want to write RFI status, actually 3 parameters. And I want to write RFI comment. What I might do is just freeze this node and run. So these are our parameter names, and then our values are coming across from here. So we need to pay attention to the levels that we're working at. So you can see at the moment that each element, its parameters sit at level 2, and the values of each of those parameters we want to sit at level 1. Our parameter names sit at level 2 as a list, but level 1 as the actual parameter name. So in this case, we're going to want to apply our parameter names based on level 2, because we want to apply each parameter to each element, and we want to apply each value from each sublist. So we want to work at level 2 for both of these. For this one, we're going to want to work across each element. So we're going to want to work at level 1. And this should set the parameter values for each element based on this list structure. So if I just save, and if I run, fingers crossed it should work. Just check my lacing, this probably needs to be longest here. Then I'll run. Okay, in this case it's something, storage type is not a number. Okay, this is where data can be quite important. So I don't want to place another set. What I might do is just use an object type and just see what format of data. Okay, so you can see that one number, a couple of numbers have snuck in to our data, which is quite frustrating. What I might do is I might go and say that we do want to read as strings, just to force our data to be strings. And then we'll just try that again. what I'll do, it should place our RFI markers. I'll just double check. Okay, I think I've undone my placement. Unfreeze. I might just close and rerun the script. Okay. And of course, then it can't process these numbers. Okay, now that's not going to work. So what I might do is just use a string from object right at the end and just convert some of these things to strings. But you may need to process this data a little bit more because some of these elements are going to get pretty ugly when they get converted, such as these numbers might become, oh, they're actually okay. Sometimes these become like 1.00000. In this case, it looks like it converted pretty cleanly. So instead, I'll feed these in as my value, and I won't read as string because we need our point by coordinates to be numbers. Let's try that. Cool. So this should place our RFI markers. You can see it's placed their number. In this case, it has actually populated some of these parameters in an unideal format. So you may need to do some data formatting as you pass your data through Dynamo. But you can see that our comments have come across, our status and our number. And if I go down to my other floor, you'll see that we've got our other statuses and our RFI markers as well, which is great. And they're really easy to find because they're a family. So all you have to do is select all, visible and view. And it's really easy. And if you really wanted to, you could literally just pass data back and forth using Excel to push these parameter markers back into each other's models. So you could almost communicate just using an Excel file, even like a Google Sheet. So there's a lot of things that I think this workflow opens up as a communication possibility. It's obviously like a poor man's version of something like BIMTrack, but I guess it's a way of thinking about ways that you can pass data using Dynamo and some more creative workflows. So hopefully that sort of helps you, James, and just gives people some ideas of how they can use Dynamo to push data, to create elements and carry data. So the files for this will be on GitHub, so the scripts will be on there as well. So James, if you've watched this and you want the scripts but you don't have time to build them, that's okay. They'll be on the GitHub. But thanks for watching today, and hopefully you found this an interesting workflow and that it was an interesting approach to I guess a problem that had a slightly more manual approach before. Because Dynamo is really good at using data to semi-automate workflows. Thanks for watching today. If you're not already following and subscribing, feel free to do so. I make usually 2 videos a week and hope to do so for a while. So thanks for watching today, and hopefully I'll see you in the next video. Thanks. Take care. Bye.